So we start the sketching now, and Povila, you will show us. Do you have the detail?
Yes.
Yeah, he will show the detail as it ended up, right?
The first thing first is a bit of a process. At least what I like to do is I always try and get references. It's quite helpful because usually the architect wants to see it as well. On the technical drawing, it's one thing, you still have to pretty much imagine how it might end up in the end. But if you just have any references of some different ideas how it might look in the end of some existing building that has similar solution to it, it's a very good idea, and it can help you as well to imagine how to do it. And the next thing that I really like to do, and pretty much every detail starts from it, it's references from some detailing books. You can just go to the library. I think they actually have exactly these editions of it's different timber details, concrete architecture, just residential or glass details. It's not too terribly detailed what you have to draw. It's more of a general principle and the idea. But for me, it's very helpful. It's almost the first step, because it gives you quite a lot of the outlines of all the different layers within the building, what you have to do. And generally this is a book that comes from Britain, so they have a smaller insulation amounts and that sort of stuff, so you have to adjust some of the variables. But as of solving an exact connection, it's usually a very good first idea of on which way should you go. And this was an actual detail that we ended up. It's a whole different story about the roof construction. It's in the beginning it was a green roof, and afterwards, when the client couldn't afford it, it ended up as just a timber skin all around the building. Main problem with it was just the fire authorities who went, "Whoa, you're not going to do it." And that's where the references as well comes in, because there was a building in Ullesminde where they had a similar timber roof, and that was the technical solution where we took in some layers of actually how to do it. So behind the timber cladding, what you don't see, it's 2 layers of plywood and the roofing felt behind it to establish a complete waterproof layer, which is as well a bit more fire resistant afterwards. The main approach what we did is, since there's an existing brick wall on the ground floor, it's fairly difficult to integrate any downpipe into it. It was just extending the timber outside of the building, which is the thing that most of you did in the beginning, and that's the way to do it. Then you just take in all the rainwater outside of the insulation, outside of the windboard. It's on the other side of entire insulated, all the building envelope. And I've seen some projects where they actually do and try to make like a U-shaped recess in the insulation. But that's usually in the projects where you have some factories, storage areas where you can accept a minimized insulation on the other side, because you get the thermal bridge in that layer. And depending on how close it's actually made, it still can be a bit of a tough thing to actually see any problems with the downpipe that might occur in the end. Every time you have it completely concealed, it increases the chances of something going on, and that was the same case we had to make for the client, because with this sort of thing, he has to maintain the gutters. There's just no other choice for it. And a lot of people tend to clean it once in a decade. It's just never got to it. Every time you design something, just try and look what might be good about it, what might be the problems, and it's sort of a quality check plus the actual information for the client. Because if he says, "I don't want to do the maintenance," then you have to start all over again. It's a completely different solution of how to do it. Other issue that we had fairly big complications with was the ventilation. It's a fairly large amount of insulation in the roof, and you have to ventilate it. Otherwise, get the condensation at some points. We try to take in a bit of a different approach with actually water permeable subroof. But just because of that kind of amount of insulation in it, engineers just said, no, it's highly unlikely that it's going to work the way it should. And as it turned out, it's two fairly big flashings to actually cover up the insulated cavity for ventilation. All the air has to go from all the way underneath. If you stop it somewhere here, for example, you can just get the wind pressure driving the water back inside the ventilated cavity. So there's quite a lot of risks involved in the actual implementation of it. The other thing that helps a little bit in this position is the actual cellulose insulation, because it can take in a little bit of water if something happens, because with this, the actual ventilation is quite obstructed. You're not going to get the airflow as you would get in just a normal way. It's going to be quite reduced amounts of it. You still get quite a lot of extraction at the ridge of the roof, so it sucks the air in, but as it is fairly obstructed, then if you get smaller amounts of condensation in it, then it can actually be taken up in the insulation layer and then released during the summer months afterwards. The other thing was the actual ventilation of the timber cladding. In the beginning it was more closed, so in the end it's actually quite helpful since it has like a centimeter in between. In the winter time it's not entirely closed cladding, so you just get the air circulation through the cavities. If it would be completely closed cladding, I would say that this is highly unlikely that it's going to work. You're going to get the ventilated cavity down here, which is, in the winter time, it's basically dead. There's going to be quite a little of ventilation going on, and that might be a big problem to it. Every time you try to do something like this, just try and pinpoint the points that might give you the biggest problems, and I think you can actually solve quite a lot of complicated details. Just take some references, do your own sketches, and try and see what you combine. I think it was a bit of a mistake I didn't mention you in the beginning, that you can just manipulate the detail quite loosely, because sometimes in order to accommodate a certain architectural wish and outlook, you have to change the materials. You not always have the possibility of pretty much achieving the same detail with any type of roof surface. So that's the thing. I think I'm actually done. Any questions?
Yes. In the big one of the two ventilated cavities in the roof construction, is the insulation exposed to the ventilated cavity, or is there any sort of membrane between?
As long as
exactly.
this is 30 or half a meter,
yeah,
you're pretty much safe. Then
okay.
You can leave the insulation exposed. If you don't have a good enough windbreaker here, then you have to cover it up with something.
Something diffusion open, something.
Yeah, you're always going to get a little bit of a wind-driven moisture into the ventilation cavity. And as long as you have a fairly good windbreaker on top of it, then you're good. And in our case, it was the cellulose insulation, so anything that passes the windbreaker, it can be taken up into the insulation and driven back later. And for now, it actually works.
What is the type of gully, and is that like custom made, or you just use the standard type?
It's just the standard size downpipe and the standard size gutter. I think this particular comes from Rheinzink, and since it's the roof is divided into so many areas, that's the reason why it can be this small. Because you have 4 downpipes on the building, and it's 4 different roof areas that you have to take care of. I think it was just like maybe 25 square meters of roof that comes on one gutter. It was really small areas, and that's the other thing that you might take into the account, is it really much depends on precise surface of the roof. We had a similar problem with the middle glass area. Because the client, they talked about installing the gutter and actually looked into different solutions how to do it. But the manufacturer of all the glass surfaces, he just went, it's the waste of time. Because the glass is, there's almost no friction, the water gets such a speed out of it, it just skips through the gutter and it's pretty much standing there silly. So it might affect the size of your gutter when you know exact material of the roof that you're using.
Okay. Thank you very much.
That's all.
Yeah.